Hello everyone, welcome back to the YouTube channel. So let's imagine placing an order on Amazon right now. Within seconds, you get an email confirmation and your inventory gets updated. Also, the dashboard reflects all the new numbers and a warehouse machine already knows your package exists in the system. How does that actually happens? So when I started learning system design initially, I always wondered, does the order service sits there making an API call to every single one of these systems one by one? Or because if it does, that sounds like an absolute nightmare, right? To maintain that kind of system. So let's draw what that looks like in today's video. Let's begin. So let's start with the traditional architecture. Say you are building a standard e-commerce app. A customer hits buy now and you need to blast emails, update inventory, ping shipping and update analytics. The easiest way is to just hardcode direct HTTP calls to every service. It works fine at first. Then product management walks in and says, "Hey, can we send a WhatsApp notification too?" Cool, right? Toss in another API call. Next week it's a fraud detection service, another API call. Then a machine learning recommendation engine, another API call. And suddenly, this one poor order service has to know the exact IP address or domain of literally every team in the company. If the analytics team sneezes and their server goes down, your entire checkout flow crashes as well. That is the definition of tight coupling. Adding a single new feature means digging into core checkout code, and no engineers want to touch that code that has 10 different microservices hanging off it. We need a way to pull these apart. That's where events save the day. So basically, if we talk about events more, the publish ones and notify everyone. So imagine instead of micromanaging downstream services, what if the order service just shouted into the void, "Hey, an order was created," then walked away. No waiting for response, no keeping track of who's listening, no caring if they are even awake. Just fire the event and move on to the next customer. This is exactly why Amazon SNS exists, the simple notification service. Think of SNS like an airport announcement system. The gate agent doesn't individually call 180 passengers on their personal cell phones to say the flight is boarding. They make an announcement over the speaker. The people who care stand up, everyone else keep reading their book. SNS uses the exact same philosophy. The producer publishes a message once and the consumer decides if they give a damn. In that, there is also an topic, the fan out architecture. Let's see what that means. So, for the fan out architecture in system engineering, we call this pattern fan out. One message goes into the central hub and it instantly splits into multiple independently streams. An SQS cube holds onto it so the inventory team can update stock at their own pace. A Lambda function fast to stream the data straight into your data warehouse. The best part of it, these systems don't know the other exist. So if analytic service breaks down at 2 in the morning, who cares? Customer still gets the confirmation email and the inventory still process it. Failures are locked into a room instead of tearing down the entire house. Now that's the theory makes sense about the whole picture for Amazon simple notification service. So let's break it down to a real demo on Amazon AWS console. So let's keep things that simple for this demo. We'll sign up a topic called order created in Amazon SNS and wire up two subscribers, one human and one machine. Subscriber 1 is my basically Gmail inbox and subscriber 2 is an SQS queue named inventory processing over in the SNS dashboard. So I'll open simple notification service on my AWS console. You can click on topic and we'll create a topic. We create a standard topic for this demo. I can name the topic as order created. All the other things we can leave as default. Now you can see the topic has been created in Amazon SNS. As we discussed, we'll create two subscriptions. One, the email notification, and another one is an SQS queue. So let's go ahead and create one email one. So I can see the topic I have selected is order created and a region key of it. Protocol would be email. You can see the SQS one as well, and there are other as well, HTTP, HTTPS, SMS as well, and a few other things. Let's select email. You can add your email ID here. Other things like subscription filter policies and all you can enable. There is a redrive policies as well, which is useful in dead letter queue concept, which we'll be looking into in future videos as well. So let's create it. So you can see subscription to the order created successfully for this email endpoint, and the status is pending. So I need to approve this on my email so that it gets approved. If I go back to the topic, I can see the email one has been added. So to add the SQS, we need to create one simple queue service as well. So if you don't know how we created a simple queue service and how that works, the overall concept of Amazon simple queue service, you can watch my previous video as well. I have explained there about it and how it works. So we'll open SQS. We'll create a queue. We can name our queue as inventory processing. All the configurations we can leave as default. Encryption we are disabling for now so that we can easily send the message. Let's create it. So our queue is created with the name inventory processing. Now let's go back to our SNS console. Topic, order created. Give me a second, I'll just approve the email part here. So you can see this email. The subscription has been confirmed for that particular email. So if I reload the page, the status will change to confirmed. Now let's add a second consumer for it, the SQS queue inventory part. I'll create subscription one more. I'll go to protocol. I'll select Amazon SQS. You can see the SQS which we created is displaying here. The inventory processing. I'll select it. Let's create it. Done. Now we can see there are two subscriptions for one SNS, which is order created. So that's literally one topic with two subscribers. A couple of clicks, and we have decoupled the entire system into two separate parts. So let's test it by publishing a mock payload. For the subject, let's write order created, and for the message body, we can paste something like this. So we'll go to publish message. Let's add a subject call created. Message ID, group ID, we can leave empty. Time to live, TTL, we can also leave it empty for now. I have a sample JSON already ready. I'll just copy paste that. This is our sample JSON which we'll be sending. So it has the order ID, the customer, my name, and the product, and the amount of that product. You can add message attributes as well. There are a lot of things. So let's hit publish message. Boom, the message has been published. If I pull up my email client and refresh, so I can see that message instantly arriving onto my email. Okay, you can see the order has been created and I have received the email with order ID, customer and product and amount on my Gmail. Let's open SQS and see whether the message has been arrived there or not. So let's go back to SQS, simple queue service, inventory processing. Now, if I need to click send and receive messages, we need to poll the messages to look at the same. What are they available in the queues? Let's poll it. I can see there is a message arrived with type notification. The subject name is order created, which we send it, and the entire message, which is intended. So once publish call, two totally different destinations, zero direct connections between them. If marketing comes to you tomorrow wanting WhatsApp alerts, you don't touch the checkout service code. You just click create subscription again, right? As simple as that. One quick heads up. Notice how SNS wrapped our original JSON inside its own metadata object. So when you write code to consume this from SQS, remember you will need to pass this outer wrapper and grab the message string to get your actual payload. It trips up everyone the first time. So let's go on to another topic, which is you might be thinking about what is the difference between SNS and SQS. It's a massive point of confusion for people new to AWS. Why do I need both? Aren't they doing the same thing? Not at all. They are actually built to work together. SNS is all about broadcasting. It pushes message out to anyone listening right now. If nobody is listening, the message drops. SQS is all about persistence. It stores messages safely in a line until a worker comes along to pull them out and process them. Think of it, it's a way like SNS says, hey everyone, listen up, something just happened. SQS says, got it, I'll hold on to this piece of paper until someone has time to work on it. So one spreads the word, the other guarantees the work gets done. There is a whole difference on these two. So let's look at a bigger scale example like DoorDash or Uber Eats. A user orders burrito. The push notification engine needs to ping you on your phone. The driver assignment system needs to find a courier. And the restaurant tablet needs to start buzzing. The data warehouse needs to log the revenue as well at the same time. Trying to orchestrate all of that using synchronous REST APIs is a ticket straight to the architectural chaos. Instead, the main app sends a single message like order place event to an SNS topic. Every internal team just hook their own microservices to that topic, like we hooked two subscriptions, an email one and an SQS queue. No giant web of dependencies, no merge conflicts in the checkout repositories, just a clean isolation. And that's how modern event driven architectures are made. At the end of the day, SNS isn't just a tool for texting users, it's the architecture glue. Producers focus purely on generating events. SNS handles the heavy lifting of distribution. Consumers live in their own isolated worlds, deciding how to react. Once you stop forcing services to ask, who do I need to call next, and start letting them ask, what just happened, your system gets incredibly easy to reason about. Next up, we'll look at AWS Event Bridge as well and more details on it. which handles this even smarter with filtering rules. Until then, keep building, keep breaking things, and I'll catch you in the next one. Thank you for watching this video. If you do like it, do subscribe the channel. See you in the next one.